Hi everyone. The topic that we're going to discuss today is building ML products. And if you ask me why you should care, it's because of the sheer amount of data that is generated every day. We generate about 2.5 quintillion bytes of data, and it is only growing. Machine learning cannot solve problems that humans cannot solve. It can do so rather quickly, and it is relevant to every field that has access to data, be it healthcare, retail, social media, transportation, customer service, or marketing. Before we dive right in, a little bit about myself. I'm a product leader at Amazon, and very recently I was managing Deals, which is one of the first launched and biggest products at Amazon. I've used ML extensively to drive personalization, relevance, similarity, and sourcing recommendation. I'm currently working on a yet to be launched product that uses computer vision to solve a unique customer pain point. Prior to that, I've had diverse experience across sales, marketing, brand management, and user growth. I have an MBA from INSEAD. Let's get started. A little bit of theory before we understand the 101 of product management with ML. We've all used ML and AI interchangeably, so it's pretty important to understand what these different terms are. As the slide says, AI is the overall superset. Think of AI as basically helping machines make human like decisions, helping machines mimicking human behavior. It's basically a bunch of if else statements that will help machines decide. An example could be a chatbot. AI began in 1950s. Researchers realized that mimicking human behavior is not sufficient, and it's important for machines to mimic how humans learn. And that's where machine learning began, sometime in 1950s, where the algorithm consumes a lot of data and based on it, generates a bunch of output. An example could be segmentation and classification. Uh, Very recently, sometime around 2010, is when deep learning began. That's the point at which researchers realized that mimicking human learning behavior is not sufficient and it's important to mimic human brains. And that's where neural networks came into picture. So deep learning is all about human networks. So everything related to speech recognition, handwriting recognition, etc., which is still hard for a machine learning from the 1980s to solve for, would essentially be deep learning. Now that we know what deep learning is, what ML is, and what AI is, let's understand the different types of ML that's available. The first is called supervised machine learning. It's basically where you have a set of inputs and have a set of outputs. And there is a correlation between an input and output. And what the machine has to do is learn from these correlations and predict the next value. An example could be regression models. Another example could be classification. Now let's talk about unsupervised learning. Unsupervised learning is when there is no clear data tables. There's just a lot of data, but there's no clear distinction between an input and an output. The machine has to learn patterns. An example would be clustering, right? Where the machine realizes that these demographics are probably similar to each other in terms of their purchase behavior, etc. There is no clear input, no output. It's just machines learning and grouping and categorizing data. Finally, there's reinforcement learning. Reinforcement learning is it's slightly complex and different, right? So reinforcement learning is all about machines taking certain decisions, taking certain actions, and learning from the consequences. The decisions could either be an erroneous decision or it could be the right decision, in which case, if it's a right decision, the machine is rewarded. If it's an erroneous decision, the machine could be penalized. And based on this, the machine learns what to do next. An example, all of robotics basically falls under reinforcement learning. So that's pretty much about the basics about ML, right? Now that we know what different types of ML is, I think the first important question that we need to answer and that all of us need to understand is when should we incorporate ML into our products, or when should we build ML products? How do we make this decision? And the answer to this is similar to any other product management or product 101 course, right? The answer to this is start with the customer problem. Um, so to be very honest, in the field of ML, which is extremely, if it is rapid, it's a rapidly growing field, right? And you have various different stakeholders. For instance, you would have ML scientists who would be working simultaneously and alongside you. They would come up with a lot of innovation, a lot of ML models, a lot of ideas, which they believe would be the right solution for business. So in the field of ML, there's actually a push and pull, right? There are your ML scientists who will come up with some solutions, and then there is the customer problem, right? So it's not a sequential decision making, and which is why it's always important for the product manager to step back and whether you start, I mean, if there is a solution that pops up, right, it's important for you to step back. If there is a real customer problem that you're going to address with the solution, never productionize or never implement an ML solution in an ML model because it's cool or it's likely to give impact. Always start with the customer problem. Start with the customer, what the customer problem is, why is it a problem, figure out how to solve the problem, and see if ML is the right tool to use. Always think of ML as a tool and not as the field, right? Um, I'll in subsequent slides, I'll take you through some more examples and use cases, right? How do we decide if ML is the right solution, correct? So the first question that you need to answer is, when there is a customer problem, can you try solving the problem with simple computation or simple heuristic algorithms? Yes or no? If it is a yes, do not use ML. The reason is ML is not simple. ML is iterative. ML is expensive. And ML is hard to maintain. So do not get into ML unless it is absolutely required. The second question that you need to answer is, if there is an element of personalization that's required, if there is an element of personalization, more often than not, you will need ML. Do you need it to adapt? Do you need a solution to adapt real time, like every second? More often than not, you will need ML. And finally, do you want it to scale up really fast? More often than not, you will need ML. And finally, once you've decided that you need ML, you need to be very sure. Go back and look at data. The data has to be clean. The data has to be, you need to have sufficient, relevant, and clean data. Without this, you will not be able to achieve right results and outcomes with ML. I'm going to use the subsequent slides to talk about some examples in terms and use cases as to when you may need ML and when you may not need ML to kind of just, drive this right in. We're going to talk about ranking first. Ranking is a very often used case of ML. And we're going to see when we may need ML and when we may not need ML. So the first use case is I'm going to talk about examples from my experiences. I'm going to talk about Amazon deals first, right? In a very early or a post-launch stage. This happened to so what happens in an early stage or an immediately launched stage is that you pretty much will have very few deals that are run every day, a handful of deals, maybe 1,000 deals, right? And the customer problem or the customer we will see at that point in time is, I want to see the best deals on Amazon. I want to know what's the best deal that I should buy. Now, if you go back to this VOC, can you use a simple algorithm? Can you use a simple computation to address this use case? Yes, you could potentially just figure out which deal sold the most number of units or generated the most revenue in the last 1 hour and show that on top. You'll be solving the ranking problem of, I want to see the best deals on Amazon. You do not need an MO. Do you need it to adapt real time? No. Customers are okay with a 15 minutes or 30 minutes latency in saying the best deals. Now, the third important question, do you have a lot of relevant data? No. When you've just launched, you probably have less than a years of data, you probably don't have sufficient data, right? You'd be launching category by category, selection by selection. So you don't have enough data for ML to drive incremental experience here. So this is a use case where you do not need ML. You could just resort to simple heuristic algorithms, which we do even today at Amazon. Now let's talk about another use case in a mature established market, right? So this is a market that's been running for, let's say, 5 or 6 years. You have sufficient data. And what happens in terms of behavior in a mature market is you have thousands of deals that are run every day. For instance, in India, we have about 15,000 deals that are run every day. A lot of them are good deals and best deals, right? The predominant VOC at this point in time is that I want to see the most relevant deals to me. I want to see deals that are most relevant to me, what I am likely to buy, categories I am interested in. I don't want to see a mobile deal. I want to see a fashion deal. Now, in this case, can a simple algorithm solve a problem? No. Do we need personalization? Yes, because every customer has a different preference. We need to understand what drives this preference and recommend deals based on that. Do we have enough relevant data? Yes, because it's a mature market. We have over 2 years of data. So we would be able to use ML. So this is a use case where we need ML. I'm going to now just pause for a second so that you kind of take this in, right? So an early market with limited data where the VOC is to see best deals, we do not need ML. A mature market where we have sufficient data and where the VOC is personalization, we will need ML. I'm going to talk about another example. I'm going to talk about similar products next. It's another predominant use case. Do we need ML? Most likely, yes. And the reason is scale. Here's an example from Amazon Store Merchandising. On the left-hand side is a use case, right, where a customer says that during Christmas event, I want to see all products related to Christmas together in one store. So I need one store that has all Christmas-related products. For this use case, we do not need ML. And the reason is a merchandise, because ML actually does not make decisions better than humans. It just makes them faster, right? So you could have like a merchandiser or an expert in the field of Christmas sit together and put together products related to Christmas together into one store. The minute this pivots into a customer VOC where, like in a market like India, where we have a festival every month, we have multiple festivals every day. In fact, over the last week, we've had 3 festivals. Small set of population, each of these festivals is relevant to a small set of population. But customers from that population want to see products related to that festival in a thematic store. So we potentially have hundreds of Christmas-like store every year. Now, in this use case, would you need ML? Yes, because it's a problem of scale. ML is going to do a repetitive task that a merchandiser can do just every day. So that's why we will need ML here. I'm going to talk about the next topic, right? Demand forecasting. Demand forecasting is it's a predominant and common use case for ML. But I'm going to talk about something called non-stationary universe and talk about how cautious we have to be when we choose to use ML. What is a non-stationary universe? A non-stationary universe is basically a rapidly changing environment. In a rapidly changing environment, a past is not the best predictor of future. And in this case, ML will not be able to add value because ML learns from past actions, past decisions, past data, and predicts future based on these past behaviors. I'll give you an example. Let's say I'm a demand forecasting manager in a mobile phone company, all right? And let's talk about, say, the period around 2012, 13, 14, 15, when the landscape was fast changing, dynamic, rapid. There were different features that were getting launched every month, every quarter. The life cycle of a product was very short, 6 months, and then there would be an upgrade, which would basically make the previous version redundant or a dinosaur, right? So, in a category that has a very short life cycle and in a rapidly changing landscape, like in mobiles, I need to forecast demand. Can I use ML here? Yes, you can use ML, but it's probably not the best decision because the past is different from future, right? The dynamics has changed, the number of players has changed, the features have changed. So ML is probably not going to be much more better than a demand forecasting manager using simple Excel-based algorithms to forecast demand. So you might not want to use invest in ML in a non-stationary universe. Here's another example of a non-stationary universe, the most recent example, right? Let's say you're an office supplies retailer in the year 2020, 2021. COVID-19 stuck. The environment is completely changed. A lot of people have stopped going to office, but they have what's called home office. The requirements have changed, the specifications have changed. Can you use ML? No, right? Because everything about fast has changed. So you will have to adapt real time. So you will have to use human intelligence in this case because ML still does not mimic human brain. Now, a lot of macro. So, to just kind of sum this up, right? In fact, it's not just about say office supplies product in COVID-19, right? All of us who've been using ML in the past, when we continue to use ML in the year 19s, 20s, and 21s, we'll have to do it with a lot more caution to account for these changes that ML might not pick up because ML is trained on some set of data and signals. You will have to probably change those models. To kind of just sum this up, you'll have to use ML with a lot of caution in a non-stationary universe. An example of non-stationary universe could be when there is a macro environment that's changed. For example, recession, COVID-19. In India, there was something called demonetization, where the currency was we kind of just stopped circulation of certain currencies, etc. Right? These are macro environment changes. Another use case is a rapidly changing product feature and competitor dynamics. Might not want to use ML. Similarly, for a lot of new products with a new set of features, you might not want to use ML. Sorry about that. Finally, let's talk about explainability. Before we dive deep into this, this is a very often used term in the field of ML. So I want to touch upon what explainability is. Explainability is as the name goes, being able to explain why you're doing what you're doing. Why is ML predicting what it is predicting? Being able to explain that is explainability. When the customer VOC or your stakeholder VOC demands that you need a high level of explainability for various reasons. I'll get into some of it in a few minutes. You might not want to use ML. The example here is from Amazon seller recommendation, right? Now, the customer VOC is that there are a lot of deals on Amazon. Majority of them are poor quality, are deals that customers don't want to buy. They don't sell any units. So they're frustrated having to browse through so many deals that are irrelevant to them. To preserve customer experience as an Amazonian, you would hence want to assess the quality of deals that are created and prevent sellers from creating poor quality deals. You would want to tell them, hey, seller, do not create this deal because it's poor quality. I will penalize you if you do so because you're also affecting customers' delight with using this product. Now, the problem here is that when you're actually forcing a stakeholder to stopping them from creating deals or pushing them to doing something that they would not want to do, forcing them to kill something, you have to clearly tell them why you're doing so. It's important for them to understand. It's also important from a legal perspective. Now, the first question that you have to answer is, can ML actually explain very clearly? it's not accurate, right? Like an ML can tell you, for instance, hey, what would ML do in this scenario? ML would basically forecast the sell-through rate or the units that this particular deal is likely to sell based on a lot of inputs, and can say that, hey, this deal is gonna sell only 5 units, which is too minimal, so let's not create it. And it can say, hey, as I'm predicting that this is going to generate only 5 units because it's had zero sales in the last 30 days. It can give you some of these reasons, but it cannot be, it's not 100% accurate, right? Because there's so many variables, there is interplay, etc. An alternative could be a simple rule-based algorithm, right? You could basically say, hey, any product that sold less than 5 units in the last 1 month, every day, if the daily sell rate is less than 5 units, you should not configure a deal on them. Now, here is a rule that you can explain very clearly to the seller, right? There is not the, hey, my ML predicted and it predicted because of these 10, it could be because of these 10 different reasons, etc. Right? So when it is important to explain very clearly and be 100% transparent, it's better to not use ML if you can solve it using another simple rule-based algorithm. Now, we've gone through some of the examples and use cases of when and when not to use ML, right? So I assume as a product manager, that's the first step. You've looked at your customer problem. You've looked at all the different options that are available on the table to solve this customer problem. And then you've actually clearly decided that you have to use ML. It's the right path forward for you. And once you've decided that you have to use ML, we'll now use the next slides to discuss what you need to do next. What are the various things that you have to definitely account for? The first thing that you have to do is you have to create a strong acceptance criteria. You have to define for your product what your success metric is and what success is going to look at. And the reason it's important to design this upfront is because your ML algorithm, the ML model, will be developed to optimize for this success metric. A simple example, right? You decide that you want to rank the best selling deal, right? I'm just going to use simple examples here. Now, how do you define best? Is it the deal that most customers want to buy? Or is it the deal that generates most units? That's different, right? Most customers buying a product, most units, or is it the deal that generates most revenue? These are three different output metrics. One is customer metric, one is unit metric, one is revenue metric. Now, the three metrics that I've talked about are all transaction related metric. But you could also have a non-transaction related metric, such as the deal that generates most views, deals that generates most customer engagement, which is probably clicks to the next page. So there's so many different metrics. You have to clearly define what is the metric that you're going to optimize for. And your ML algorithm will optimize for it. An example, if you choose to optimize for most revenue, the ML algorithm will push to top all the deals, like potentially high ASP deals or high value deals. It could be from categories like mobile phones, electronics. These are expensive categories. If you're talking about, say, engagement metrics, where we're talking about views, click-through rates, etc., the ML algorithm might optimize for deals that drive engagement, most likely from categories like fashion and home products, because customers are going to look through a lot of products before designing. If you're looking for deals that generates most customers, units, etc., the ML algorithm will potentially push on top deals from categories like grocery, right? Consumables. These are like your diapers, etc., right? Like customers quickly buy if it's on deal. So it's extremely important for you right at the get-go to define and align on the success metric and the success criteria, which is plus or minus 5%, etc., right? Because the ML algorithm is going to optimize for it. I'll explain over the next step what happens, right? Once you've defined on the acceptance criteria. Once you define the acceptance criteria, you have to involve the right people. This is exactly same as in any other product. You need to start with a sponsor, someone from the leadership who is going to support you and sponsor this particular product. And then the important stakeholders for you are the ML scientists and the software development engineers. What your ML scientists would do, your ML scientists actually, the field of ML is very collaborative. You have to brainstorm often, right? Your ideas are not going to come from you. It's probably going to come from your ML scientists. They're equal stakeholders to the product manager. What the ML scientist is going to do once you've defined the problem statement and the acceptance criteria is he's going to come back to you with a model that's going to solve your problem. He or she will use raw data, convert it into training data, and then build an ML product that you could use. The ML scientist will also do a lot of what is called an offline analysis. This is basically trying to prove that the ML model works in a non-production, non-online mode, right? On some of the past data, on test data, right? On some of the test data, basically. To kind of drive confidence that this model, when productionized, is going to work. And then you need your software development engineers and your data engineers as well, ML engineers as well, to productionize the model and deploy the model in real time. Right? This would involve components, just feature engineering, getting the right feature in, building the right architecture that's going to help us to experiment with multiple ML models simultaneously, so on and so forth. Now, once we have the right people, I think when you define the roadmap, the one key thing that as a product manager that you have to account for when you're managing an ML product or building an ML product is that you have to build to be iterative. It's a given that the ML solution that you're productionizing might not work at get-go. It might not happen. Because learning is an iterative process. The ML model can learn as much in an offline mode. It could have been successful using offline analysis, but it could still break in production mode and online. You might have to hence roll back, learn, hypothesize based on testing and production, drive in improvements, and redeploy the model. You have to have an iterative and a learning mindset to deploy ML models. And this is important because it's going to be important for your timeline perspective. It's going to be important from a software engineering and architecture perspective in terms of how you're building the architecture. Is it iterative enough? It's going to is it wide enough for you to be able to test multiple models, etc. Right? And finally, it's important for you to build interpretability, also known as explainability, that we talked about. While we know that building explainability and interpretability is difficult in ML, as a PM, you will have to sell your product. You have to sell your product to your customers, to your stakeholders, and to your readers. And to do so, it's important to explain the output as much as you can. You could explain it in the following ways, right? You could say, hey, this ML model recommended this particular product because this is the particular variable where it outperformed. That variable that it outperformed is the last sales. I mean, sales in the last 30 days, historical sales. Or this particular product outperformed because the ML model recommended because it outperformed in recency, the last 1 day sales, last 30-second sales, whatever it is, right? Try and explain the output based on the variables that a particular like recommendation of product has actually outperformed. Because to be very honest, ML is a black box. And when it's a black box, you can always be questioned by people, right? Why is my product not ranking up? Why is mine not ranking up? And you need to be able to explain why. And finally, right, while we've done some of these, it's important to keep an eye on other engineering components because ML is only part of the puzzle. The other important part of the puzzle is engineering. All right. Availability of features, latency, right? ML model is going to consume a lot of data real time and it's going to process real time, which means that there's going to be latency, and latency can have negative impact on model performance and customer experience. Keep an eye on it. And finally, infrastructure maintenance cost, right? M&A is expensive. So how often you need what components to refresh, what components to train, what components to predict, etc. Right? So keep an eye on the infrastructure maintenance cost. Once you've built and deployed, do not ever forget to monitor and maintain your ML products, right? Some of the areas that you need to focus on would be degradation of data quality. What worked last year might not work now. Something's probably broken. Environment has changed. The second important component is change in customer context and customer problem. What they wanted last year is not what they want now. Customer looks is the problem is different. What you have to solve for is different. Third, very often, right, very common, broken ML pipeline. Something is not working somewhere. Keep an eye on it. And finally, advances in the field. It's a rapidly advancing field. There's just so much of improvements that's happening every day that it's important for us to keep reiterating and deploying better models every year. So keep an eye on it, right? And finally, I think whether we're working in the field of artificial intelligence or ML, I think it's nice. It's very nice to kind of like at least understand the basics of it, because it's gonna be it's probably gonna be a field that's going to be all around us, right? We all heard about Elon Musk and his Tesla bot, for instance. It's in the field of AI. It's going to take over a lot of redundant tasks at some point in time. So it's nice to kind of just know what it is all about to kind of be ahead of the game. Thank you so much.